Till then, it's a pleasure to present Veljko Dragšić with his talk titled Beyond Get. Welcome in.
Thanks, Nikola. My name is Veljko Dragšić. I'm going to talk about interacting with popular social media REST APIs, our experience with building one, and with one key feature, shaping the REST API responses with advanced query algebra that we implemented in our own. So, a few words about me. I work as a backend developer at Italy. I'm working on data aggregation platform for nearly 2 years. I was working on building our own REST API, and the technologies that I meet on everyday basis are Ruby. I would like to point out Celluloid, which is actor-based framework for Ruby, JavaScript, CanJS framework in JavaScript that is the product of our company Adobe, and services like PostgreSQL, RabbitMQ, Redis, and so on. So, who we deal with? These are the social media REST APIs that we deal with, except RSS and ERC that are not REST APIs. So, how many of you did some kind of integration with any of these? Like you registered your own application, get API keys, and did some integration. Okay, great. So, I will first walk you through the supported features that usually meet this kind of APIs. So, the first one is authorization. You register your application, get some kind of API keys. You usually want some kind of authorization for your clients so they can log in. And you obtain access tokens if you want to fetch some kind of private data of users. Another feature is pagination. You always do some kind of iteration. It's usually with offset params or this RFC that's hypermedia relations in HTTP headers. It's used by GitHub. You will usually hit some kind of rate limiting when you're trying to fetch too much data, and thanks God for versioning, because when somebody upgrades the API to a new version, you don't want to break the other integrations. There are some other features that are usually not supported, but are supported in some of the APIs that we integrated with. The first one is filtering. We usually want to fetch some kind of a data based on value of certain attribute in a response, like tags or something. That's only few of them, like Stack Exchange, Tumblr, some of them support something like that, but usually it's not so often. Another thing is basic search, which is usually not supported, and sorting data, like by value of some attribute in descending or ascending order. Embedding, meaning that when you, for example, fetch articles, you want to embed like comments, authors inside, questions, whatever. You usually don't get such a feature. You need to do multiple requests. First fetch an article, then see who is the author, then do additional HTTP requests for the author, for the comments, and so on. And the real-time feature is a really cool thing, if there is one, because in the other way you should make simultaneous requests all the time and check is there something new, but it's much easier when you just get a notification from the backend that something has changed, like via postback or streaming API. So, the issues that we had with these integrations. The first one is authorization. You register your application. If you want to fetch private data, you need access tokens. And maintaining access tokens, they usually expire after some time. Is implemented in every different way on every provider. Then filtering, there's a lot of overhead with the requests to filter out. You usually get a list of 100 events and then cherry pick the information that you need. Embedding, like I said, additional multiple requests. Real time, you usually just do polling of a certain API, but it's much easier to subscribe to some kind of real-time services if there is some. And data inconsistency, yeah, it really happens. Sometimes you get some kind of ID on one endpoint, you should use that ID on some other endpoint, and basically that's not the same ID, not the same object, but it should be. And, well, data unification and storage. That was our issue, that we needed somehow to unify the different types of data and store them consistently. So it usually ends up like this. Just to give you a tip, we are using Postgres with HTML and JSON extensions. They give us enough level of flexibility for storing data. So we have like strong tables, relations, and we use JSON attribute to store some kind of flexible data. So to recap, The good thing is that we are using REST APIs. They all support HTTP methods like get, pull, spot, delete, and so on. They have headers, status codes, and query params. Authorization we have all authorized, and if you get, usually you'll find a provider that suits your needs, and that really works. Basic features like I mentioned, and real-time updates only for a few of them. And we always get a JSON response. It's good because it's easily parsable, it's native in JavaScript, and well, there's not much to go after that. There are also some bad things, like I mentioned, maintaining API keys, the lack of more advanced features like filtering, embedding, sorting. When you get a JSON response, you usually don't get any kind of schema. So sometimes you get a raw JSON response, sometimes you get a payload with some kind of meta attributes and so on. Real-time updates, as I said, the one thing is like only Twitter, I think, has streaming API that you connect directly to their socket, but others will have their own implementations of postback that you register URL on your own service and then you get some kind of notifications. They're basically just doing HTTP post to the registered URL. And well, inconsistency. And the main thing is that all of them give us a little control over the structure of data and response. So we usually do multiple requests and cherry pick the information out. So we built an API that enables consumer to shape the structure of a response via advanced query algebra, and it looks like this. This is the real working example. So we are hitting some kind of endpoint, for example, events. We wanted that the responses contain tags, CanJS, and func_unit. We want that they are created in September of the current year. Order them by upvotes in descending order. Eventually do some kind of pagination, and pass some, let's say, additional attribute like this one. And, well, actually, it ended up in the slope implementation in the end. I will give a few reasons for that. So it all started as a simple service. Basically, that's the very typical story of a project that grew too much. It started as a simple service for internal use. We didn't have the clear focus and goal, and we were integrating third-party APIs on the fly, and they all differ a lot, so we were adding new features and introducing new complexity. We were altering data model and responses all the time, and that ended like these horror stories from before. That were coupled into our ORM and controllers, and consistent responses, and a lot of hacks like that without future detonation. So what we learned? We're building a standalone library that will be easily pluggable into any existing code base. The consistency is, well, the key feature in any API. We should step back and refocus what we are actually dealing with, because there are a dozen of different APIs that we are aggregating. And we implemented this advanced query algebra that lets us give us more control over the shaping of our responses that we get. So, some of the features. I will just walk through the features that we implemented. First thing is comparison. For example, we want the exact match to match certain value of attribute in the endpoint that we are hitting to be, for example, equal to webcam. Or sometimes we want to match some other values like regex or subdomains in the URL. Another feature is negation. Sometimes we want to fetch the responses, the objects that don't contain a certain word. Or check nuance or existence. Existence is very important for us because of HStore and JSON support. Sometimes we just fetch objects that don't have, there isn't attribute that we are looking for. And of course, null and exist are recent keywords in here. Ranges, like give me all the IDs that are between 100 and 200, or greater than 100, or well, open range less than 200. And also the support for other type formats, like we want to do some kind of filtering by time span. Also nesting. You're always getting some kind of a nesting object, like you get a list of questions, then you have comments, then you have answers, then you have comments of answers, outputs, and so on. So we also want to filter by the embedded documents, embedded objects inside and values. So this is the example. For example, fetch me all the articles and embed the authors inside. Or fetch me all the articles, embed the authors inside and the comments inside. or the nested values, authors and authors of the comments, and it also implies that you want to embed comments as well. Ordering by value of certain attribute in descending or ascending order, or by multiple attributes, first by one, then by second, like the standard SQL. Pagination, we only implemented a simple solution like limit offset, but sometimes some of the REST APIs implement this RFC that I mentioned, or include some kind of a pagination data into meta object into the response. And some other features like counting, summing, grouping, or any other feature. Some of them are implemented, some are like open for now. So in the end, that all ended with, well, one of the things we learned, okay, write the specification first and then start implementing things like this. So it ended up by mirroring this RFC. It's basically a specification for a specification how to write a specification. And here it is. Well, this is only a draft version, and just to give you a certain look how it looks like, but I won't stay on this too longer. And the implementation. I will just walk through the really short example of how it works. So everything starts with the HTTP request. It hits our API. Let's say that we want to fetch articles that doesn't contain tag JavaScript that were created this year. We want to embed author inside in the response and the comments and the authors of the comments, and order the result by created date timestamp in descending order. This is a really working example on our API. After that, it hits middleware that parses params and builds us a syntax hash. The good thing is that it's ORM agnostic, so that is a syntax hash that can be used by any other provider. In our case, it's Active Record, but SQL or any others. So it looks like this. We have a model that's articles that basically the endpoint we are hitting. There's some filtering options, like we want to filter by tag, by attribute tag, with the conditions that must match JavaScript and that the negation is true. Another filtering constraint is that we want created end to be starting from the beginning of the current year. And we want to embed author, comments author, and comments author imply the comment, so that wasn't in the request, but it's here. Ordered by created data attribute in descending order, and that's it. This is the bit simplified version of this syntax hash that is built in the middleware. And after that, it hits the ORM. ORM builds the actual SQL query, so we can do that, well, manually, but it's much easier to use some of the existing ORMs. And this is the plain Ruby, well, Active Record syntax. Article join author, join comments and authors, where the start date is greater than past param, and the tag doesn't include JavaScript. And ordering by created data attribute. And finally, it results the response like this one. So this is also the simplified version. So to recap, our API has a support for handling advanced query algebra, and it's shaping the responses to the user. The good thing about that is that we reduce the number of requests sent to the server, and for our use case in our client, this is really crucial. It's not agnostic, so it still sticks only with URL params. So in the whatever JavaScript framework you use, you only need to serialize the JavaScript object to URL params, and that's it. It's going to work. Certainly, it adds additional complexity and the cost in CPU and I/O, but the trade-off is for less requests. So actually, you will have more requests, and you will hit rate limiting sooner or later. You will have a really nice API that lets you pick the right data you want, and you will have less requests. So I think that's a good way to go. And yeah, actually I went a bit too fast for this, but we can talk a bit more about it if you have any questions. Hi.
So I imagine for different models you might have different fields you can search or certain options turned on or off. you expose that to the client in some way, like the hypermedia spec, or do you just sort of hard code that to the client?
Sorry about.
Do you have like when you do a GET request, for example, like can you tell the client, hey, these are the fields that are searchable in this manner, like with a hypermedia schema or JSON schema?
No. Well, yeah, it should be good. It should be great to build some kind of JSON scheme that describes the API, but usually you can only do the documentation.
Okay, thank you.
Yeah, but that's a good thing.
Any more?
Hi. Did you think about using SQL for this? Like, I don't know, it seems really similar to what SQL already does.
Yeah, basically it's translating URL params to the data model you have, and basically that ends up on SQL.
So just using SQL for this, like, I don't know, I'm just thinking about just passing a string which is actually SQL, not passing it to the database, but because there is a specification for SQL already, and it's actually a query language. So using it in the GET request, you don't need to reinvent the wheel. Did you think about this, or?
No, what's the project that handles that?
Sorry, no project.
Can I answer that? So you don't want to do that because not every REST response is married to a table in the database, and this project is supposed to work on SQL database, MongoDB, or anything. So basically, when you get that hash that is parsed, you you pass it to some other thing that knows how to filter on these params. So that's why we want to send SQL in.
Hi. I was wondering, so to understand the project, do you have a layer of abstraction that abstracts responses to various different APIs? Or
No, we aggregate all the data and we represent that in some kind of unify the data, and well, the response is pretty much the same. There's some additional attributes in some responses, but the main structure is the same.
But so there is a separate system that aggregates information from, like, when you connect to Facebook or Twitter or whatever, and stores it in your database, and you have your own API that talks to just the database.
Yeah. Yeah. We usually just extract the data, like we always have title, body, source URL, origin, timestamps, attributes like that. But that's what I said. For some additional attributes, for example, Meetup has a lot of additional attributes. We store them in place. And then when we are fetching the Meetup event from our API, we just stick that to the response. But every response can be some kind of constraints, like title, body, source URL, and so on.
Hi, two questions. So with clients specifying a lot of stuff what they want, how do you handle access rights? That's the first question. And the second is, with a lot of different requests, how do you handle caching? Because you're bound to have a very low caching of the URL itself.
Yeah, well, for this case, we didn't implement caching yet. It's only for internal use currently. And the first question was about?
Well, access rights. So if the rules for who can see what data are bound to get more complex with the users saying what they want.
We have a certain level of rights. This is a multi-tenant version. So when we are using Postgres schemas to isolate data, and when somebody has access to the schema, then he accesses all the data. So we don't have some kind of fine granularity in the rights.
Hi. From the privacy point of view, what do you do with the aggregated data from the users? Do you aggregate data? Do you collect it? Do you process it in some ways? Or are you just a pass-through service?
Well, we process it in a way that we unify the data. Every of these feeds needs to fit into our storage. And we have like, well, actually Nikita was talking about that yesterday about event sourcing. So we have like events and entities tables, and no matter what feed the data comes, it's stored in the same data structure.
Any more questions? So to answer the privacy question, since I'm working on this project too, we are only scraping the public data and showing it publicly on the site. We're not using it for any data mining. So that's for that. And I think Dikica has something to say about caching because he's the one implementing it.
So the question about caching actually works. So how we do it is that we serialize the query params, order them, and then they act as the key in the Redis. So each of these queries has a separate key. When you hit that key, you get the cached response back. So caching works on this. So you just need to store the query params. I hope that answers your question.
No, because you're going to have a low hit rate because there's the space of possible values is very big.
It's not that big. But we can talk about it later.
Yeah, it's actually bigger than other REST APIs that don't accept params like this one, so many params. It's working so far.
Okay, any more? Okay, so we're finished. Thank you, Veljko.